Hi everyone, welcome back to the channel. My name is Joseph. You are on IT.tutorials. Today we are going hands-on with one of the most important concepts in C programming, namely data types. And yes, we'll cover today the basic data types with a working example at the end. Let's go step by step. So, C language data types. What is a data type? In C programming language, data types define the type of data a variable can hold. Choosing the right data type is essential for memory efficiency and correct program behavior. C data types can be categorized into the following groups: basic data types, modified data types, derived data types, and void type. Today we are going to talk about basic data types. So these are basic data types: int, which refers to integers type; float, which can hold real numbers; double can hold also real numbers. We see later the differences between these two, float and double. And at the end we have this basic data type, char. So let's take each of them step by step. So this is the keyword used for integers type, namely int. Integers are whole numbers that can have both 0, positive and negative values, but no decimal values. So here you have a few examples of whole numbers which this type int can hold: 0, -5, 10, and so on. We can use int for declaring an integer variable. Here you have an example. Here, id is a variable of type integer. We use this keyword int to declare an integer type. And here you can see the value is a whole number used to assign this variable id. The size of int is usually 4 bytes, which represents 32 bits, because 1 byte contains 8 bits. 8 times represents 32 bits. It can hold this range of values. This is the minimal value which this type int can hold, to this value which represents the maximum value which this type int integer can hold. We use this format specifier made of this percentage symbol and letter D to print this type int. Integers do not have a fractional part. If you assign a fractional part to integer type, most C compilers will ignore the fractional part and round the number up. If you assign a number that is outside the range above here, then you will get an incorrect value. Unfortunately, the C compiler will not stop the execution of the soft or of the app. The compiler will execute the code even your value is outside of this range of values, and will print an incorrect value. So you will get a logic error actually. The next basic data types is float. Float is used to hold real numbers. The size of float is 4 bytes, which represents 32 bits. It is called also single precision float data type because it can hold up to 7 decimal digits. Here you have an example. Here b is a variable of type float because we use here this keyword float. This is the real number used to assign this float type variable b. As you can see, I used here this letter F, the end of this declaration, because I want explicitly to tell the compiler that this value, this variable, holds a float pointing numbers. If I don't put here F, then the compiler implicitly will take this number as a double type and not a float. This float type can hold this range of values from this minimum value. This is the minimum value which this type float can hold. As you can see, we use this E letter here because this is a scientific representation, because this number is huge, it's very big, and this is the maximum value which this type float can hold. Again, this type of float can hold up to 7 decimal digits. Yeah, so this type float can hold up to 7 decimal digits. That's why it's called also single precision float data type. When using floating point numbers, you should choose the appropriate data type according to your specific needs and precision requirements, and avoid using values beyond its representation range for calculation. So you need to pay attention when you use this float data type, because if the precision what you need is high and the number needs to be represented very accurately, then maybe it's better if you use double than float, because double has a higher precision than float and can represent a bigger range of values, and also can represent approximately 15 up to 17 decimal digits. So this is the most differences, the most important differences between these two data types, double and float. So the next basic data type is double. Double also is used to hold real numbers. The size of double, which is called also double precision floating point, because can hold approximately 15 up to 17 decimal digits, approximately double than the float, as you can see, is 8 bytes. So the size of this type in memory is 8 bytes, which represents 64 bits, because 8 times is 64 bits. It can hold up to 15, 17 decimal digits, as I said. Here you have an example, the declaration of double. B represents a double type variable. Here we have the number, the real number which was assigned to this variable, to this double type variable b. As you can see here, I didn't use any letter at the end of this declaration because it's not needed. Explicitly, this real number, the compiler will know it is a double type. The significand of the double type is approximately 15 to 17 decimal digits for most platforms. In most cases, a variable of type double can accurately represent 15 up to 17 decimal digits. Numbers outside this range may lose precision or be rounded. If you define a 18 digits number, the result will lose precision. Also, we use this format specifier, this percentage symbol together with F, to print this type double. And the last basic data type is char. So this is the keyword used to declare a char type or to declare a character type variables. This can hold only one character. This is very important. Here you have an example. This grade is the variable which has this type char. As you can see, this type can hold only one character, and the character is surrounded by simple quotes, as you can see. The size of the character variable is just 1 byte, which represents 8 bits. It can hold this range of value from -128 to 127. The character must be surrounded by single quotes, as I said, like these examples in here, and we use this format specifier made of percentage symbol and letter C to print this type chart. We can use ASCII values to display certain characters because all characters behind has a code ASCII, which is a number actually. Note that these values are not surrounded by codes. When you use ASCII code or a number to represent a character, you don't use the codes, yeah? Because they are numbers. And here you have a few examples. A equal with 65, because this is the ASCII code for capital A letter, 66 for a B capital letter, 67 for C capital letter. Yeah. So thank you for watching this presentation. Now, next is the fun part, a full program using everything we just learned. We are going to do it in Visual Studio Code. So let's go to the Visual Studio Code. So here is the code. As you can see, I declared a integer type variable age assigned by this value 25. As you can see, this value is a whole positive number. This temperature variable is a floating point data type, which is holding a real number, as you can see, 36.6. And the end of this declaration, there I use this F letter to tell the compiler that this is a float data type. Also, I declared a double P variable holding this real number, and here we have 15 digital decimal digits after decimal point, because this type double is able to hold from 15 up to 17 decimal digits after the decimal point. We have this char grade variable which holds this letter A. As you can see, the letter A is surrounded by a single quotes. Also, as I said, we can assign numbers in order to get the character behind the ASCII code, having this type char. As you can see, I declared the char type, and the A was assigned with this whole number 65, which actually represents the A capital letter in ASCII code. 66 represents the B capital letter in ASCII code, and was assigned to this variable B, which has also this type char, and C was assigned by this whole number 67, which has this type also char, and this number actually represents the C capital letter. Now you can see how we can declare multiple variables on the single line using a single type, in this case char, and all of this variable being separated by this comma. Using this printf statement, we are going to print out the result in terminal. And here the last declaration, I try to draw your attention, because here, as you can see, I use these char variables which are holding these whole numbers, and the result you will see in terminal will be the letter which these whole numbers are represent as a code ASCII for certain characters. Okay, let's execute this up, and here you go. As you can see, we have here capital A for 65, capital B for 66, and capital C for 67. So In this video, you learn all the basic data types in C and how to write a clean working C programming using the basic data types in C. In the example you can see on my screen. If you found this tutorial helpful, drop a comment, give it a like, share with your friends this C programming tutorial, and don't forget to subscribe for more coding content. Thanks for watching, and I see you in the next video tutorial about C programming. Until then, happy coding in C. Have a lovely day. See you next time. Bye bye.